how to use your graphical calculator, and we're obviously going to run through a little one of these together on a Teams call at some point, but this will hopefully give you a little bit of a more static and run through where you can kind of go back and review and all those sort of things on terms of, I'm going to move that across a little bit because it's just a bit, there we go, it's better. So I am going to splice in this video to some ones I found online, which are very good little walkthroughs about showing you the actual button clicks. And obviously I will talk to you about how to do those when we share the screen with you of the graphical calculator. But this is just going to be how to do this question here, which is from your winter exam, and how your graphical calculator can basically do all the heavy lifting for you. So first thing you do, you see this question, it's question 5, and I'm going to have the whole question in so you can see the whole question at all the times, and we're going to break it down into the different sections. So first thing you should do when you make sure your iPad isn't locked. First thing you need to do is make sure you type in the equation. So fx, you go into the little graph function, you'll see that we have put them in brackets because we want the numerator and denominator in separately, and I've just used the slash function here for division to show that it's a numerator and a denominator. So you type the first function in because it asks you to sketch. So we're doing this question here. It says sketch the graph. You don't need to think about where it goes. You don't need to think about doing a table of values. All you do is say, calculator, please show me what this graph looks like. You can obviously see I'm going to keep the answers down here so you can always refer back to them for all these little slides. And you do that and it will display you something like this. Now you notice that my sketch is that I've actually done. This is probably what you would do on your actual question, and it's not, doesn't have to be perfect, okay, but it's just a rough representation. The key thing to note is that you make sure that there's a clear line where they aren't crossing here and here and here, so there's bits of the graph that aren't filled in for a graph like this, and I've just put in a couple of little markers for myself to help me with my scale, and that's absolutely fine. So now we've got a sketch of our graph, we can start to answer the questions. So we go to the questions, let's see what they look like. First one asks us to find a local maximum. You can see that the good news is the calculator can do this for you. On the little drop down menu you can see we've gone to analyze graph and then maximum, and that gets you, obviously it's going to tell us where the maximum is. It says a local maximum, so we don't want the maximum because obviously this graph here would go on forever and ever and ever upwards, but that's not what we're looking for. We want a local maximum, so we just want to know the maximum on the graph that we can see, which is going to be the top, any point where there's like a top, a lid, or whatever you want to think of it as. So we click on this, and when you click on the local maximum option on your calculator, it asks you to, you'll set like a between here and here. So obviously I said a first dotted line, second dotted line. So I said from here to here, tell me where the maximum is between, and you can see it labels it there, and it gives us a coordinate. Once you click enter, it says, yep, there's your coordinate, and it gives you the answer. Now you can see that they've given it 3 significant figures, but the calculator only gives it to you for this one here. But again, that's absolutely fine. Do not worry too much about that. Okay, if you gave that answer, you'll be absolutely fine. So that's maximum. Again, we can see that straight away the calculator has done everything for us. We're just writing down what we see. Next question asks us to find the asymptotes. Now asymptotes are, in case we have forgotten from last year, asymptotes are basically, if you imagine a line where the graph can't go. If you look at this first part of the graph here, okay, it kind of starts going up, and then all of a sudden at this point at the top, so once it keeps going up, it can't go up anymore, and then it jumps down from here to here. So at some point it stops being the first part of the graph and starts being the second part. And there's like a line where that graph is going that it can't go across. So it's like, not on highlighter, sorry. There's like a line that it's saying, oh, well actually it stops being an up graph and starts being a upside down U. Similarly, we can see that there's the same thing here, where it stops being a U and starts being this one in the top left. And horizontally, we can also see that there's a bit here where it can't go to. It's just, it keeps going closer and closer and closer and closer and never gets to it, and similarly on the other side. Now I'm just going to splice this video with another one that's a really good online example I found that I downloaded, so that shows you how to do asymptotes using the trace function and also using a table of values. So I'll just let that video play through now.
This video is going over how to identify asymptotes of a function. Okay, so I've got the function 6x squared minus 12x plus 5 over x cubed plus 5x minus 6, and then plus 3. Okay, so listen to that. I'll use brackets. 6x squared minus 12x plus 5 outside the brackets divided by bracket x cubed to the power of 3 out of the power plus 5x minus 6 outside the brackets, then plus 3. Enter. Okay, so here's a very interesting function. I'm just going to move the label up here. Okay, it's making some very interesting things. So once again, as explained in a previous section, you can find the minimum point there using menu, analyze graph, and then minimum. Now we can find the y-intercept here, we can find the x-intercept here, which is at 1, and the y-intercept we could just use the trace function. So if I go menu, trace, graph trace, it actually started at the y-intercept, so 0, 2.17, so the y-intercept is y equals 2.17. Now to find the asymptotes of the function, we can go find a table of values. So press menu, table, and split screen table. And here we can see in the first column is the x values, 1, 2, 3, 4, and then we've got the y values in the second column. Now by scrolling up and down, we can see the y values for negative numbers, negative values of x, and positive values of x. Here we can see we are undefined at x equals 1. So what does that mean? That means there must be a vertical asymptote at x equals 1. Okay, so if we go back to the graph, so I'll just click this on the edge, let it flow and press delete. Okay, so what's happening at x equals 1? If we look at our actual function, why would it be undefined at x equals 1? Well, look at the denominator. What if we substitute 1 into there? You get 1 plus 5 times 1, which is 5. So 1 plus 5 is 6, minus 6 is 0. My function is undefined at 1 because the denominator is 0. So therefore there is in fact a vertical asymptote at x equals 1. So to find asymptotes, you can either trace it or better yet, use a table of values. Again, if we wanted to find the horizontal asymptote that way, we can go menu, table. Now, let's have a look what happens as x approaches infinity. So remember, this is the x values here, and these are the fx values or y values. So if I go down, what's happening? I'm getting closer and closer to 3. And then if I go up, back to, so towards negative infinity, where x equals negative infinity, so I'm finally in the negative numbers now. What's happening? 2.8, 2.9, and I've got a feeling each of these digits are going to turn into 9, 9, 9, 9, slowly like that. So 2.97, and so forth. So as we can see, we're again approaching 3 in the negative direction. So the table of values is probably the best way to work out where the asymptotes are. It tells you where the function is undefined, and by scrolling up and down, you can find what the function is approaching as x approaches negative infinity and as x approaches positive infinity. In both ways, they were 3. And the vertical asymptote was x equals 1.
And how to do the looking at the table of values, so looking at the table and seeing what numbers are getting really close to, and obviously with the trace function, when you're tracing it, it should kind of be tracing, and then all of a sudden it jumps, and then where that point jumps, you know that's your asymptote. So you should have got these 3 lines here if you've done that correctly. And you'll notice that you did the vertical asymptotes with the jumping, like by the trace, and then the horizontal asymptote would have been by looking at the table of values. And you'll see that you got 3 results. You see that the 2 vertical lines, which are x equals lines, so you can see that you can't get a value of x as -3, you can't get a value of x as 2, the graph tries to just jump. Similarly, when you look at the table of values, you'll see that for whatever values you put in for x, it keeps getting closer and closer and closer to +2. And so that tells you that those 3 asymptotes are the 2 verticals and the 1 horizontal, which we can see on the graph. And those, of course, are the values that we get for the asymptotes. Just remember, they're bits that the graph can't go to. They get really, really close, really close, but not quite there. Okay. Then, the good news is, next question says, find the value of k when fx equals k has no solutions. Now, what you'll notice on there is I've kind of combined the information we got from the first 2 questions. We know that the local maximum, which we were given, okay, gives us this little point here. I'll highlight it for you, that little point there. That was okay, but it can't go above that. That's the top of that line. Similarly, we knew that this line here, y is equal to 2, we said it can't go below that line. So you see I've kind of shaded a space in between. We know that it says no solutions, i.e. there are no points, the graph doesn't go into that space. So what we're saying is, okay, well we can see in that little space there, and I can highlight it maybe a nice pink or something. Okay, in this space here, there isn't anything, there's no points, the graph doesn't go into that area. So therefore there'll be no solutions.
We're talking about this area here, which is the area where there are no points, there is no graph. And if we look at that point there, well we can see the line cuts off at y is equal to 2. So when it's less than 2, we know that there is going to be no value. We also know that when it is greater than -0.833. Now we know that -0.833 does exist, and we're looking for the ones that don't exist. They have no solutions. So -0.833 can't be included on the doesn't exist because it does. However, we know that asymptote y is 2 is saying, well, 2 is when it starts not existing. So we include 2 as well. So we add that little less than or equal to. And of course, we want to find the value of k. So k is in the middle because it's that range. It's below 2, but above -0.833. And that's obviously this here. Okay, the next question asks us to find when fx is equal to g of x, and it gives us the g of x is the 2 vertical lines, x plus 1. Hopefully we all know that this means absolute. And maybe we'll talk a little bit more about what absolute values are, but basically we know for the simplistic level, we know that this means that x plus 1 has to give us a positive solution. If we get a -1, we just take the number and ignore the negative symbol. To type this in, first thing we need to do is you need to add another function. So if you see here, I've highlighted the different ways you can do this. So we graph and then enter another function, which is on our menu. And it will prompt us, just like we did when we did the 2x squared minus x plus 5. It asks us to add in the second function. It doesn't give us g, it just says f2 as in a new function, the second function. But we use abs and then brackets. Even though they're curvy brackets, they'll change to straight lines when we press enter. And we put ABS, obviously for absolute. It's the key next to the 9 if using the keypad. When you type that in, it will look something like this. And as you can see, it's this line that's just been added in red that I'm just going to highlight for you. And because of, like we were just saying, it can't become a negative value. So once it gets down to the x-axis, it flicks back up and mirrors in the opposite direction. So what we're looking for is the 2 yellow dots, which are the intersections, and they're going to be our solutions. Remember, we're solving for x, not for y and x. So we look at those 2 values there, and you think, don't worry, we don't have to read them off the graph. As I said before, the calculator will do the work for you. So once you've got that graph and you've drawn it on, you then say, okay, I want to find an intersection. So you go to your menu, and you go to Analyze Graph, and then Intersection. There's a specific function for intersection. And when you click on this, it will give you a little, you can move it around with a little keypad, little cursor, and it will look something like this. And what you want to do is you want to say, okay, you can see on the graph where it crosses. So like this first one, it's where the red line crosses the blue line. And you set the first line to the left of it and the second line to the right of it. So you'll click, move the cursor, click, and it will look something like this. And then you repeat the same process for this one over here. So I'm not going to show you how to do it twice because it's do exactly the same thing, but you do have to do it twice. Okay, it won't pick up all of them. And what you can't do is say start the line here and end the line there, because it will only pick up one at a time. So one intersection you need to do is once per intersection. So you do that for the first one. You say start here, end here, and it will give you the intersection. You can see it gives you the coordinate. And then you repeat the same thing and it will leave you with two values like so. Now remember, we are solving for x, not for y and x. It says f of x and g of x. So we're saying, well, actually the y value is not at this stage important to us. So we're just going to ignore it. You're just looking at the x values. Negative 5.13, 2.81, and you can see from the answers that that is our solution. And that's it. We're going to use that information for the next question though. The final question, which is the inequality. Now this is the one that requires a little bit of logic. So remember, it says the only thing that's changed is the symbol. It's not now equal, okay, it's greater than. So we know when they're the same as those two coordinates that we've marked. We know that we want it to be greater than. So it wants to be above, bigger, more, whatever you want to think. But just think greater than means above. If we look at this line here, we can see that, for example, where I've shaded in pink is below the red line or below g of x, but we want to know when it's above. But we know that it doesn't keep going up forever because it obviously comes down to here. All of this is below the bit I've just highlighted in pink, so we can ignore that. But we also want to know this bit here, which is above. So we want to know those two parts there. Now we have to go right back to the first question, where we said that we knew two of the asymptotes were x is -3 and x is 2. And those are those vertical lines that I've drawn in there. We know that 2 and -3 are like the cutoff lines, as asymptotes. We know that from the previous question we just did that we have -5.13 here, and at the other end we've got 2.81. And the yellow bits are where the line is above the red line being g of x and the blue line being f of x. So we can see in those shaded yellow spaces is when it's above. So we just need to know, well, where is it above the line? So we take that first section. I'm going to highlight it, the numbers in green for you. You can see it from -5.13 to -3. It's above the line. So we can say when x is more than 5.13, sorry, -5.13, but it's got to be to the left. See the arrows pointing to the left? The left of -3. We also have the second yellow set, which is between 2 and 2.81. That's the kind of orange values. So we know 2 is on the left, 2.81 is on the right, and x is between those two. And that's our solution to the inequalities. Again, the calculator's doing most of the calculation for you. You just need to be reading off the graph. So, to summarize, what are the things we've done with the graph? Well, I've tried to put it all together in one information. You can see that you can do asymptote questions. I can never spell asymptote. We can do maximum, and obviously we can also do minimums as well. It's the same method, just in reverse. So instead of clicking maximum on the calculator, you click minimum. You can do intersections, so you can do when f of x is equal to g of x, or you can do when it's greater than or less than. Okay, so you can do solutions, and all of these things can be plotted using your calculator, so the absolutes as well. Okay, and even the sketch. So hopefully that gives you a little run through of how that question can be answered using the calculator. You'll notice there's not a huge amount of work apart from typing in the right thing. It's just reading the right thing off. And we're going to try one of these together at some, well, over the course of this lesson, or a couple of these. So let's see how that goes. Good luck.